Okay, let's try part C only of question 48 at the end of chapter 9. All the parts are quite similar, so we just picked this one as an example. We've got, excuse me, hydrogen gas reacting with manganese oxide. That would be manganese 4 oxide, because oxygen is always 2 minus. Going to the product of manganese oxide, again, sounds the same, but if we were writing it as a name, it would be manganese 2 oxide. Roman numeral, plus water vapor. What mass of water vapor is formed? What is the limiting reagent? I think looking at this, we know that hydrogen gas is going to have a much smaller, as we know, molar mass than a heavy metal oxide like manganese oxide. And it's pretty clear that they, even when I convert to moles, that I don't have the same number of moles of hydrogen gas as manganese oxide. And if I had to guess, I would say that the manganese oxide will be limiting because there's not a whole lot there. But let's go through the motions and find out what is the limiting reactant. You have to find out which of the two are limiting because that is the one that determines how much mass of product will form. So do both scenarios. If H2 is the limiting reactant, calculate how much mass of product will form. If manganese oxide were the limiting reactant, find out what mass of water vapor product would form. Take that reactant, which produces the lesser amount of product. So in this calculation, we can see that only 0.207 grams of water are formed from the reaction, complete reaction of 1 gram of manganese oxide, assuming there's enough H2. Whereas if H2 were limiting and MnO2 were in excess, it would make 0.94 grams of water. But there's only enough manganese oxide present to form 0.207 grams of water. So clearly at the end of this reaction, all of the hydrogen gas will be used up. It's the limiting reagent. It goes to 0. And a lot of the original manganese oxide will still be there. So although this question does not ask for how much of each reactant is left over after the reaction, I might ask that on the final exam. So in this case, no grams of H2 are left because it's the limiting reagent. And I haven't calculated the mass of MnO2 left over. However, I think you know how to do that. And we'll actually do that one in class. I might even do this question in class, that part of it. So let's just answer the question that the book is asking of us here. And so it is 0.207 and manganese oxide is in fact the limiting reagent. Okay, so again, when they ask you how much product is forming, it doesn't matter which one to determine the limiting reagent, but I'm going to use this one because they're also asking me how much product is forming, so I can answer both questions at the same time. If this is the limiting reagent, then 1 gram converted to moles, and then through a balanced equation, there's 1 mole of water comes out of the reaction of 1 mole of H2. Convert that to moles of water and then mass of water, then 8.94 grams of water might result. You might be thinking, how can I get almost 9 grams of water if I only have 1 gram of hydrogen? But remember, it's the mass of this and the mass of this. And if hydrogen were limiting, all of the 1 gram would be used up, and then whatever amount of manganese oxide I would need to match that to form the 8.94 grams of water would be used up. So I know that 1 plus 1 is not going to equal 8. So yeah, if you're thinking along that lines, that's good. So I don't know what else to say about this question. It's pretty straightforward, I think. Just include all of your units and show that cancellation. I haven't crossed out terms here, but we can see that everything lines up to cancel to give us finally the units of grams of H2O.